So let's compare these two graphs. The graphs of y equals x squared, which is what we will call our parent graph. Y equals x squared is our parent graph. Okay, and y x squared plus 1 is the, okay, so this should be black. The green one is y equals x squared. Okay, so that is our parent graph. So the black is y equals x squared. That's our parent graph. So let's compare our parent graph to the green one. Okay, so if I trace the parent graph here, you could see that it's the green graph is the same as the parent graph, only it translated, or it slide up 1 unit. Okay, so you could see it's the same graph, but it translated 1 unit up. So can you guess what will happen if I put an x squared plus 5 here? You're right, it will move 5 units. So the graph will be 1, 2, 3, 4, 5. Okay, we don't even have to do a table for that. Okay, we know the tendency, if we keep on adding number there, it will just go up. Okay, so what about if we add 1 not on the x squared, but we add it on the x? So I hope I filled up the table. I hope you did too. So it will be negative 3, 4, negative 2, 1, negative 1, 0. Okay, so I'm going to plot that. I'm going to use red. So negative 3, 4. So negative 3. Okay. 1, 2, 3, 4. Negative 2 is 1. I'm following this table here. Okay. The table that we are doing, that we did before. So negative 3, 4, negative 2, 1, negative 1, 0. 0, 1. 1, 4. 1, 2, 3, 4. And 2, 9. 5, 6, 7, 8, 9. Okay. So this is our red graph. Okay. So before we go there, I forgot. Let's try to first see the different properties of the green graph. Let's go back to the green graph, and then I'm going back to the red graph. Okay. So what is our vertex of the green graph? This is the lowest point. Our vertex is 0, 1. Okay. What is our line of symmetry? Or I will just say LOS, line of symmetry. So it's still the y-axis. Okay, y-axis, or the line x equals 0. Our x-intercept, there is no x-intercept. The green graph did not cross the x-axis. What about your y-intercept? Where is it now? Here, on the point 0, 1, the same as our vertex. Okay, domain. What is our domain? Domain is always all real number for all parabola. Range for this one, you started at 1 up to positive infinity. Okay, so your homework will be like that. I will be giving you table to fill up, and then you will graph them, and then you will give me this summary. Let's call this the summary. Okay, so that will be your homework. Now let's go to the red graph. Okay, so the red graph, let's join the points. Okay, so here, and then it started going up again. Okay, up to here. So by symmetry, I know that there will also be the next line will be here too, right? You see, this is the vertex, this is symmetrical, this is symmetrical. So I'm going to find the symmetry of this. Okay, so 1, 2, and 3. Even if I don't have the table, I know that it will pass there. Okay, so where is the line of symmetry of this red graph? Okay, I hope you find that the middle line for that is this one here. That's the line of symmetry. That's the line that cuts the graph into two equal parts, and it's always where the vertex is. That's the middle part. Okay, so what do you notice? So this graph is x squared, x plus 1 squared. So let's compare that to our black graph. Okay, so this is our parent graph. Again, we say it went 1 up. Okay, for the grid, it went 1 to the left. It's exactly the same graph. Okay, so it translated 1 unit to the left. So if it is plus there, it's 1 to the left. If it is 10, that's 10 to the left. If it is 3, plus 3, so it will go from the original to 1, 2, and 3. That will be the graph. And that is called translation. Okay? Translation. Okay, so that is what we call translation. So let's find the properties of the red graph. So what is our vertex? Where is your vertex? Where is your lowest point? At negative 1, 0. Okay? Negative 1, 0. Where is your line of symmetry of the red graph? Is the line x equals negative 1. Okay, it's the line x equals negative 1. It's the middle. If you cut your parabola into 2, that's where you will cut it, right? Then x-intercept, where is your x-intercept? Is on negative 1, 0 here. It crosses your x-axis. Negative 1, 0. Where is your y-intercept? Where did the graph cross the y-axis? Here on this point, right? Here is the x-axis. Here is the y-axis. So 0, 1. Y-intercept is 0, 1. And then, what else do we get? Domain. What's your domain? Okay, it's left and right. So it's negative infinity to all real numbers. Negative infinity to positive infinity. And what is your range? Okay, 0 to positive infinity. Okay, so that is just 2 examples. Okay, so first graph the parent graph, and then do the table in your homework. Okay, I want 1 graph each. So maybe in the homework, I'm going to make you graph x squared plus, let's say, plus 3, or y equals, what about if it is x squared minus? What happens? X squared minus. Okay, so that is maybe x squared minus 4. Or I will ask you to graph x minus, x squared. Okay, x squared plus 3. This will go up. I think this will go down. If you have x minus 5 squared, this will go 5 to the right. Okay, and what will happen if you have negative x squared? Or if you have 3x squared. So these are the types of homework I'm going to give you. Okay, and you will see. Okay, compare it with the parent graph. I'll show you how to do the homework on the next video.